All right there. Now we're continuing with chapter 9. I got just a tiny bit cut off there at the end, but I was just saying that, if you don't have Excel 2010, feel sad because it's easier to work with, but, there's ways around it. And of course, my Excel videos, the old ones, show how to use 2007. All right, now we're going to build a confidence interval here, just like we did for the proportions. But the thing to keep in mind about these confidence intervals is you need a couple things. You need your data to be random, of course, and independent and not biased. Then you need it to come from a normal distribution. Because if it doesn't come from a normal distribution, then you're in a whole other planet of statistics, namely non-parametric statistics, which we won't cover in this course. And I have this pickpocket data from before, and I wanted to know, does that data come from a population that is normally distributed? And does it have no outliers? Because those are kind of key to being able to work with these confidence intervals with this formula, is that you need to know that it's normal with no outliers. So why did they draw these graphs? Because here, as the sample size is less than 30, we need to verify that the data is from a normally distributed population with no outliers. If I could spell outliers. There you go. So that's why you have to do that, because it's a requirement for working with intervals, with the t-interval. Are the other requirements for creating a confidence interval satisfied? Well, let's see. So was this data from a simple random experiment? Let's go back and remind ourselves about the pickpocket data. There it is. It was from a simple random sample, so that's good. We didn't have n greater than 30, but that's okay. And then was there anything else? Oh, independent. Well, of course, you're not going to have one pickpocket case is not going to affect the other pickpocket case. So the data is from a simple random sample and the data values are independent. So yes, the data was independent and from a simple random sample. Cool. Now it says to construct, except I deleted this for you guys. So using Excel or StatCrunch, to be honest. I'm going to probably use both. So let's start with the formula. So the formula is x bar plus or minus, that symbol's over here, plus or minus t alpha divided by 2 times s over the square root of n. Cool. So we're going to have to go find x bar and s and n for that pickpocket data. So let me pull up that data in Excel. Hold on. All right, so here's the data all lined up for the losses, and we need x bar and s in order to be able to find all of this. We also need n, although that's really easy to find. It's 25, but I can show you how to do it with Excel as well. So let me pull this up again. All right, so the mean, because you just need to have it, is the average of all these numbers. Okay, standard deviation, because this is a sample, is equal to ST. Now with me, it's stdev.s. The old school, it was just stdev. Because I have newer Excel, it's stdev.s. They're reminding you that it's a sample, which I prefer, but otherwise it's just stdev. And in case you're wondering, sample size n is equal to count. And you can have it count how many values there are. I know there's 25, but I just think it's cool. Okay, so we're going to have to substitute into this formula. I doubt I'm going to have time, but let me try. All right, poof, there's everything. The one problem we have here is the T alpha. I want to show you again how to find that in Excel, but it's going to take us more than 10 seconds to do. So let me hold off on that and show that to you in the next video, and I'll finish this formula out then and show you how to do it in Excel as well.